Hey guys, Mr. Wilson here. We're going to go over this enrichment that goes along with your Polygon angle sum theorem notes. Just making sure you get a little bit of guidance how to do this so we can find out our Polygon interior angle sum theorem. Okay, so this first section asks us to draw the diagonals in the following polygons. Okay, a diagonal is just from one vertex to an opposite vertex on a non-adjacent side. And so in a quadrilateral, 4 sides, I'm going from this vertex to this vertex. Okay, these other two are on the same side or share sides, so I won't touch it. How many diagonals are here? 1. Okay, in this pentagon, 5 sides, you can pick any side you want to, or any vertex you want to, and then go to its draw its diagonals. 1 here, 1 here. There are 2 diagonals. Okay, you probably get the gist. I'll continue this until it's done, just to make sure you guys see what's happening. Okay, and that's okay. So I drew 3 lines. That's 3 diagonals. Sorry, that paper's moving along a lot. Okay. You probably see what's happening as we go and add a side. Now we're adding a diagonal. Okay. Keep going. Adding a diagonal. This is a diagonal. Notice even if I tried to do it here, it would just be a line on the shape, so I'm not going to try there. That's 4. Okay. Octagon. Keep going. Alright, now this is really going to be used for us to fill in this table down below. And as we talk about the polygon angle sum, I believe this is concave. I'm try to draw the diagonals anyway. 2, 3, 4, 5, and then I have one more here. You say 6. Alright, let's pin this. Starting to go out on me. Alright, so we have 5 here, 6 here. Alright, so notice that as we increase in size, in the number of sides, we increase in the number of diagonals we're able to draw. Okay, so when we have a triangle, we really don't have any diagonals. I know that's not drawn here, but there's no way that we can draw a diagonal without just overlapping a side, so we have no diagonals. How many triangles do we have in a triangle? 1. What's the degree in the triangle? From our triangle angle sum theorem, we know that every triangle adds up to 180 degrees. Alright, now this is where our diagonals help us out. Quadrilateral. How many diagonals do we have? We have 1. How many triangles does it make? It makes 2. So the total degrees in a quadrilateral? 360. Okay, that's 5 sides. How many diagonals do we make? 2. How many triangles are there? 1, 2, 3. Okay, and you guys should see the pattern. As we increase in number of sides, we increase in number of diagonals. Okay, Okay. As we increase in number of diagonals, we increase in number of triangles we have. Okay. So that'll be 4, 5, 6, 7, Alright, and so as we do that, we increase in the number of degrees. So 540, 720, 900, 1080, 1260, Alright. So, what we're going to do is find out how we can find out the number of, the total measure of degrees. Well, what we see here is that what we're doing is we're finding the number of triangles and we're multiplying it by 180. And so the number of triangles is always 1 less than the number of diagonals. or sorry, one more than the number of diagonals. You can think of it that way. I guess this is n minus 3, n minus 3, n minus 3, n minus 3, n being the number of sides, and the number of triangles is n minus 2. So this is the really important part. We have n minus 2, and to find out how many degrees are in a triangle, in our polygon, we say 180 times n minus 2. This is the polygon angle sum theorem. Okay, that's the polygon angle sum theorem, is that we can find the degrees, the measure of total degrees the total degree measure in a polygon by doing n minus 2, the number of triangles in the figure if we draw diagonals, times 180. How many degrees are in each triangle? Alright, open to the back. Polygon angle sum theorem. As we look at these, we're going to try to find the measure of the missing angles. So what we have here, we have 90. These two, they tell us that they're the same. So now what we're going to do, we have 1, 2, 3, 4, 5 sides. 1, 2, 3, 4, 5 sides. And so now we can say, okay, well, if there's 5 sides, we know the total should be 180 times 5 minus 2. It's 180 times 3, which is 540. Am I right? 540. Alright, and so I can find out these missing angles because I'm just going to call them x. And they show us that they're the same. So I have 90 plus 115 plus 2x plus 85. And I add these angles together, 90 plus 115 plus 85 gives me 290. So 540 equals 290 plus 2x. 540 minus 290 is about 250. Okay, 250 equals 2x, and that means x is going to equal 125. Okay, now m is an exterior angle made from AB. Find the value of m. We would find this value because this is a straight line. This is a linear pair. They make up 180 degrees. So m is going to be 90. Okay. Alright, we're going to look at BC. It says continue BC to make an exterior angle. Okay, if we do that here, we found this was 125. What will this angle be? Well, again, 180 minus 125 will give us 55. Okay, they want us to continue CD and try to make that an exterior angle. Okay, so again, these two make up a straight line. What will they add up to be? 180. So that makes this 95. Continue DE. Well, DE is 125. 125 plus 55 will give us 180. Continue EA. Okay, 115 plus 65 will give us 180. Okay, how many exterior angles do we make? 1, 2, 3, 4, 5. What are the sum of the exterior angles? If we add all these together, we have 95 plus, sorry, I gotta make sure I'm starting at the right spot. I started down here. 95 plus 55 plus 65 plus 90 plus 55. 360. Okay, does this work all the time? Let's see. Let's check. Let's draw an equiangular triangle. Okay, if I draw an equiangular triangle, that means all these angles are going to be the same. It means they're all 60. If I continue my straight lines, let me make sure I do that. Okay, so that means that this will be, if this is 60, that means this will be 120. This will be 120. It means this will be 120. What are all three of my exterior angles add up to? 360. Okay, in a polygon, the exterior angles will always add to give you 360. Alright, so that's the interior angle polygon sum theorem and the exterior angle polygon sum theorem. Alright, continue the notes.